Hi everyone, welcome back. So previously we talked about constant pressure process. This is one of the five processes that we'll be looking at for this particular chapter, a perfect gas. The next process we want to look at is the constant temperature process. Okay, if you remember previously we talked about the fact that your internal energy is a function of purely temperature, which means it is proportional to temperature, and eventually the scientists managed to come up with the equation that mCV_T is your internal energy. Okay, if temperature does not change, your internal energy does not change. So this has got to do with the constant temperature process. Okay, you realize that if the process does not change in temperature, it means the initial state T1 will have the same temperature as the final state T2. Okay, and it also means that your U2 is equals to your U1. So if U2 equals U1, delta U is equals to 0. Okay, and remember your first law, Q minus W equals to delta U, which is equals to 0, which means Q is effectively equals to, heat transfer is effectively equals to work done. Okay, we will go talk about this a bit later, but in chapter 4, in section 4.5, okay, page 57, if you look at this, okay, P1 V1 equals T over T1 equals P2 V2 over T2. If my temperatures are the same, the equation becomes P1 V1 equals to P2 V2. This is the so-called Boyle's law. It means that my pressure is actually inversely proportional to volume. If as pressure increases, volume will decrease. Okay, and vice versa. Volume increases, pressure will decrease. Okay, so this is Boyle's law. And the subsequent pages, right, shows you how to derive the equations, the formulas for work done, change in internal energy, which is 0, okay, and heat transfer. Okay, and let's talk about example 4-4. Okay, so an air is a flexible vessel. So my V1 is 400 liters. Okay, 1000 liter is 1 meter cube, so this is 0.4 meter cube. P1 is 0.12 bar, which is 12,000 Pascal. Okay, and T1 is 35 degrees Celsius, plus 273 is 308 Kelvin. Okay, 308 Kelvin. So it is compressed isothermally. Compressed, that's the keyword. Okay, second, isothermal means the temperature is the same. So volume now becomes 0.23 meter cube. So what is the heat transfer and work done? Of course, heat transfer is going to be the work done since delta U is 0. So we just need to find one of them. Okay. You also know that R is 287 joules per kilogram Kelvin and Cp is 1005 joules per kilogram Kelvin. With this, you can find your Cv is Cp minus R, which is 718. And then after that you go to your page 67, the formula table, constant temperature. What do we have? We have volume 1 and volume 2. We have R and we have T. We are able to use MRT, natural log V2 over V1. Okay, this will give us the work done and the heat transfer. Or should we not use that because we do not have mass? Although we can find mass, but you can save your number of steps by just using the other formula, P1 V1 natural log V2 over V1. Okay, P1 V1 or P2 V2, it doesn't matter because they are the same. Remember your Boyle's law? Okay, so if you have this, you use this. If you have this, then you use this. It's the same. Okay, so it will be 12,000 times 0.4 times natural log 0.23 over 0.4. Okay, if a natural log of a number less than 1, you get a negative over here. So the heat transfer and the work done, right, is actually a negative value. 6 joules. Okay, so work is also minus 2656 joules. If it is a negative work, then it is a work input. Okay, work is input into the fluid. That's called, it's called work input. If the fluid is doing work, it is a work output. Okay, so this is for constant temperature. Okay, the third one is a constant volume. The PV graph, the curve of constant volume looks like this. Okay, it goes vertically down because there's no change in the x-axis volume. Okay, because of this, right, if there is no change in volume, it means that there's no moving, there's no motion, there's no expansion or compression. It means that your work done is 0. Okay, work is always associated with moving parts. Okay, if there is no change in volume, right, it means that work is 0. Okay, so constant volume process means work is 0. And because of this, based on your first law, your Q will be equals to your delta U. So just keep in mind of this. And again, subsequent pages helps you derive the delta U, Q, and W. And let's look at example 4-5. So the keyword, if you see the question has the word rigid vessel, it means that it is a constant volume process. Okay, so V1 equals to V2 equals to 0.2 meter cube. T1 equals to 25 plus 273, 298 Kelvin. Atmospheric pressure, which is 1.01325 bar. Alright, was heated up to 95 degrees Celsius, so T2 is 95 plus 273, 368 Kelvin. Am I right? Yeah, 368 Kelvin. So find the final pressure and the change in internal energy. Okay, so again, let's look at the formula table. This time it's constant volume. You look at this row. Final pressure, and we use this equation here to find the final pressure. Okay, P2 over T2 equals to P1 over T1. Therefore, P2 is P1 over T1 times T2. Alright. Times 368 divided by 298. 125,126 Pascal. Okay. And your change in internal energy is your Q. It's the same as your Q. So constant volume, which is MCV T2 minus T1. MCV T2 minus T1. Okay, we do not have mass, right? So we find it. Let me see. So first P1 V1 equals MRT1. So my mass is 101325 times 0.2 over, this is air, so the R is 287, okay, times temperature 1, 298. So it's 0.237 kilograms. Okay. Yeah, so I use this 0.237 times CV is 718. Please be careful, don't use 0.718, okay? That is in terms of kilojoules, which is not an SI unit. So 368 minus 298. You will get 11.91 kilojoules. Alright. Question here, you see T1, T2 minus T1, right? I'm using in terms of Kelvin. 368 minus 298. Okay. Some people may question, if I use 95 degrees Celsius minus 25 degrees Celsius, will it be the same? Yes. Okay, because the increase is 70 degrees here, the increase is also 70 degrees here. So when talking about delta, a change, okay, it doesn't matter whether you're using Kelvin or degrees Celsius. Okay? When you're looking about you're only looking at the T2 minus T1, the difference. So it should be the same.